Class, welcome back to another video. Today we move forward. We're technically in 4.3 now. We're including imaginaries. Alright, so we're going to do some easier stuff to start, just to kind of reintroduce the idea of imaginaries to you, and then we'll move on from there. Alright, so this first example, it says that we need to solve a quadratic, but in the complex number system now, okay? We're not talking reals anymore, we're talking complex. So we can have i's. That's what that means. We can have i's. Alright, so we use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Perfect, okay? Keep that in mind, practice it. It's not going away anytime soon. So let's think about this. X equals 4 plus or minus the square root of, I don't know why I said 4. 2! I'm terrible. I was squaring it early. This is a positive 2. Sorry guys. There's my 4. Minus 4 times 1 times 5. All over 2. Alright, sorry about that again, guys. Okay. Let's see what's going on now. This can simplify a little bit to x is equal to 2 plus or minus the square root of, well, this is negative 20 or minus 20. So 4 minus 20 is negative 16, and this is all over 2. Alright, let's keep going. This is what I'm getting at. Normally, or maybe the other day, we would have seen this and we would have said, no solution, can't factor, this is all you have. But now, because we can use the complex number system, I need to simplify this more. 2 plus or minus. Now, what we do here is, remember, we always take the negative 1 out, right? The square root of negative 1 is I. So I know I'm going to have an I. And what's left over? Well, the square root of 16. Still all over 2. Okay, all I did was I removed the negative and I put an I. If I keep going, this is nice. Alright, what I'm going to do is I'm going to split this up just so I can see both pieces, right? Remember, we need to use the heart. So now I have that x is equal to 2 over 2 plus or minus 4i over 2, or x is equal to 1 plus or minus 2i. Okay, and that would be my solution. Now, some people might find it helpful to write it out separately. Feel free to do that. If that helps you understand that there's two solutions, go for it. It would be 1 plus 2i and 1 minus 2i. Alright, so again, we use the quadratic formula, we plug everything in correctly, don't make mistakes like me, and then you just start simplifying until you get to your solutions. Alright, let's try one more. I'm not going to rewrite the quadratic formula every time, okay? I might just be singing in my head. So x is equal to, let's see, negative b, so 1 plus or minus the square root of 1 minus 4 times 1 times 1 all over 2. Alright, we can do this. X is equal to 1 plus or minus, what do we got there? Negative 3 all over 2. Now remember what we do. Because there's a negative under the radical, we remove that negative, but we replace it with an I. Okay, because again, negative 1, square root of negative 1, I'm sorry, is I. So this becomes x is equal to 1 plus or minus the square root of 3 times I all over 2. Alright, the last thing I would do is I would circle, I want to see my answer a little nicer than this, and I'm going to say x is equal to 1/2 plus or minus root 3 over 2 I. Alright, so this is more than okay for an answer. I'm okay with that. If you want to separate it, feel free. Okay, easy enough, I hope. All right, we're going to be doing this quite a bit, so this is good practice and good to know. Now, the next thing we're jumping into, the fundamental theorem of algebra. It sounds super fancy and whatnot. All it's really saying, guys, is it's actually changing what we said a few videos ago. If you remember, a few videos ago, we said that if a polynomial had nth degree, then there were at most n solutions. But the keyword, and I actually just missed it there, at most n real solutions, okay? What we are going to say is no matter what now, every polynomial of degree n has exactly n complex solutions. All right? Exactly n complex solutions. Now you need to understand that this is made up. Here I go again. Can't wait to get yelled at. All right. Has exactly n complex solutions. You have to understand, though, there are two things that make this up. Two things. I have one side, which are real solutions, and what I need you to know about this is that those are my zeros or x-intercepts. All right? So there's some number of real solutions, and then there are also imaginary solutions. Okay, solutions that involve I. And what we say for these is not zeros or x-intercepts. All right, these are the ones we have to graph. These are the ones that still make up the polynomial, but we don't really see them necessarily at the x-axis. Okay? All right. Let's see here. The conjugate pairs theorem. This is pretty nice, and hopefully we can see it like from our two examples above. What happened here? When I had 4i in this case, it was always plus or minus, right? So I always ended up getting two solutions. Or here I had plus or minus again, so I had two solutions. What I need you to understand here is that if I have a 0 at a plus bi, there has to be one at a minus bi. That's the conjugate pair theorem. These are conjugates of each other. If you have one, you have the other. Or if you have this one, then you have that one. All right? So I learned this one from Miss Braytek. We can call this the buy one, get one method. All right? BOGO. It's BOGO. All right? If you get one, you automatically get the other, which is really nice. So, as we take a look something or like something down here at the bottom, where I tell you that the polynomial has a degree of 5, but I only give you 3 of the zeros, well, let's take a look. 1, that's a real 0. We don't have to use the conjugate pair theorem here. But 5i, what do we say here? 5i is imaginary, and that means that it has its conjugate, or it has a conjugate, I should say. All right? The conjugate is negative 5i. Now please be really careful. Understand where the negative goes. Please notice nothing changes. Like if you look back here, it's a plus bi and a minus bi. The real part of these conjugates stayed the same. It was just the imaginary part that flipped signs. So that's why I flip this sign, and that means that I flip the positive I to a negative I to get its conjugate. All right, so now I know that the other two zeros are negative 5i and 1 minus I, so that's good. The last thing that I want to do, and I know it doesn't say, this is our answer. Okay, this is the answer, so let's make sure I know this. I do want to just practice writing it in factored form too, though, okay? So if we were to write this in factored form, we'd have f of x equals, then we don't know the leading coefficient, so we'd put an a, but then remember, if there's degree of 5, then there needs to be 5 sets of parentheses. All right, the first set of parentheses is going to be nice and easy. If a 0 is a 1, x minus 1. What about if my 0 was 5i? x minus 5i? How about negative 5i? Easy enough, right? X plus 5i. Now these are the two you just got to be really careful about. Remember that you're subtracting, or it's the opposite of how it looks. So you're changing the signs everywhere. So here, if I'm looking at this 1 plus I, it's going to have to be x minus 1 minus I, because I have to flip the signs. What happens when I take my last one? X minus 1 plus I. All right? So this was just good practice for you to understand how to write these in their factored form. Let's jump in to some specific examples that might look very similar to something that you'll see both on class or in the classwork and then on tests. And just a quick reminder, when it says to write the equation of a polynomial, we need to fully distribute. Okay? I want it fully distributed. Sorry. All right? So, let's take a look. Find a polynomial of degree 4, leading coefficient 1. Coefficients are real numbers, and then we have 3 zeros. This is good. All right? We're on the right track. Let's see what's going on here. So I'm going to write everything that I can to start. I know that I have a function. I know the leading coefficient is 1. I know the degree is 4, so I need 1, 2, 3, 4 sets of parentheses. What's super easy? We know for sure a 0 of 1 means I have an x minus 1, and a 0 of negative 1 means I have a factor of x plus 1. Now, please remember, this is imaginary. It has a conjugate. That is another 0. Okay, I have a 0 at negative 4 plus I, which means I have to have another 0 at negative 4 minus I. So I write x, change the signs, so plus 4 minus I, and x plus 4 plus I. All right. Now, I don't have to worry about this 1 anymore as I start to kind of distribute. X minus 1, x plus 1. What's going on here? X squared minus 1, right? That's easy. What I want you to understand is what we really did there. We said that this was like an A value. This was like a B. And whenever you multiply A minus B times A plus B, you always get A squared minus B squared, right? It's just the reverse of difference of squares. What I want you to understand, and this is a method that you're going to need to practice, is this is actually the same exact thing. Okay, I do not want you taking this x and distributing it everywhere, and then coming back and taking the 4 and distributing it everywhere, and same with the negative I. That's a lot of work. It's a lot of room for error. Make this easier on yourselves. What I want you to understand here, and I know it's kind of goofy, it's going to take practice, but if I underline this x plus 4, and then I maybe take a color or I squiggle for my other, x plus 4 is the same here, I is the same here, 1 is minus, 1 is plus. It's the exact same thing that we saw over here. This is A, this is minus B, this is plus B, so we know what we have to do. We have to write A squared minus B squared, okay? So that was for the first one. Now, I'm going to use big brackets here just because it might get a little messy. I need to write my A value squared, so x plus 4 squared, and then minus my B value squared. Again, I took A squared, I took B squared, and I'm minusing them, just like we did on the side before, or this part over here. Okay? Let's keep going. F of x equals x squared minus 1. Now, we know, let's see here, x plus 4 squared, that's going to be what? X squared plus 8x plus 16. Now we need to subtract I squared, but we know that I squared is always what? Negative 1. All right, so when we clean this up, we get x squared plus 8x plus 17. All right. So again, if we didn't quite get it the first time, maybe either rewatch it, or we are going to do one more problem like this on the next page. I need you to understand that this is just an a minus b, a plus b situation. All right? It might take some practice, but we can do this. Now, I don't have any great suggestions for the rest. This is just going to kind of be what we've done in the past, all right? You just got to do it. All right, let's see here. One thing I guess I will try and do, though, is I'll try to stay a little bit more organized. And I'll show you what I mean by that, okay? So when I do x squared times x squared, I get x to the fourth, and then x squared times positive 8x is plus 8x cubed. And then what do we got? 17x squared? All right, that's when I distributed all of that. Now I go back. What I'm going to do, guys, I'm going to change colors and just show you what I'm thinking here. I'm going to do this negative 1 times x squared. I'm going to write it right underneath. I'm going to stay a little bit more organized so I can really see all of my spaces. All right, this will be minus 8x and minus 17. And again, I'm just thinking this way because it might be helpful to kind of see what goes with what instead of having to find squiggles and stuff like that to find the excuse me, the like terms. All right, so I finish this up by writing everything. X to the fourth plus 8x cubed plus 16x squared minus 8x minus 17, and I believe I'm done. Okay, we found that polynomial. Now the last thing, it does ask us to graph. I'll make sure to move my paper. I'm going to set up an axis, or coordinate plane, sorry. Not the best coordinate plane. Ooh. Use everything we've got to help us out with this, all right? I know from my new polynomial, my polynomial in standard form, that I have a y-intercept of negative 17. So that is a point. I also know my end behavior from this standard form. It's positive and it's even, so it's going to be up, up. Let's see here. What else can we do? Well, it's not quite, you can't really tell from here, but if we go back to the original, didn't we have some real zeros? We had a real 0 at 1 and at negative 1. So I can make x-intercepts there. All right. The very last thing you need to comprehend and kind of think about here is, can I plot any more x-intercepts from these two? No, that's the whole idea. The only zeros or x-intercepts on my graph are coming from real factors, not the imaginary factors. All right. So the last thing I would do is I would come here. I know it's kind of goofy looking. You got to grab it, go through, pick up the y-intercept, then come back through the 1, and then finish up. Guys, if you didn't have these curves, that's fine. If you didn't draw your arrows, I care about the end behavior, I care about the correct x-intercepts, and I care about the correct y-intercept. All right? Okay. One more, and then we are done. Let's check this one out. I think it's going to be really similar to the one before. Whoa, too far. Okay. So if we look at this, still polynomial of degree 4, leading coefficient of 1, so 1, 2, 3, 4 sets of parentheses. It's a good start. Now let's take a look at what we have. Whose coefficients are real numbers and have zeros? 2, multiplicity of 2, so I can say x minus 2, x minus 2. And then 2 minus I, which means, what's that last one, guys? Oh, I'm going the wrong way, sorry. What's my last 0? 2 plus I. So now I write it. X minus 2 plus I from this one, because I have to change the signs everywhere, and x minus 2 minus I. All right. Now, as we move on, f of x, we don't have to worry about the 1 anymore. We know that x minus 2 times x minus 2 is x squared minus 4x plus 4, right? That looks good. What we need to do is we need to practice, and actually I'm going to change this to a square bracket so we can really see what's going on here. Alright, I need to figure out what my a and my b are in this situation. I see an x minus 2 and an x minus 2. That's my a. I see a plus I and a minus I. That is my b. Okay, I have a plus b, a minus b. This always multiplies to a squared minus b squared. A squared minus b squared. A squared minus b squared. Okay, so I have a squared minus b squared. And then I will close that up. Alright, so let's continue on. This becomes, or this stays I should say, this becomes x squared, oh, it's the same exact thing that we just did, x squared minus 4x plus 4, and then we have minus this negative 1. Alright, hopefully we remember, right, I squared, sorry that's an I squared is always negative 1. So this cleans up not that nicely, but to something like this. Alright, now are we done? No, this is not fully distributed. Keep distributing. It's not going to be pretty, but we can do this. Alright, f of x equals, I'm going to stick with green for my first set. So x squared times x squared is x to the fourth. X squared times negative 4x is negative 4x cubed. And then a positive 5x squared. Now I move on. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 4x is positive 16x squared. Negative 4x times positive 5 is negative 20x. 4 times x squared is 4x squared. 4 times negative 4 is negative 16x. And lastly, 4 times positive 5 is positive 20. Alright, so when we combine all of this stuff together, when we combine everything together, we get x to the fourth minus 8x cubed, 5, 21, 25, 25x squared minus 36x plus 20. Alright, the last thing we have to do is graph it. We can do this. We use all of our hints. We've been doing this. We know how to do this. We know that we have a y-intercept at 20, correct? What else do we know? We know that we have an x-intercept wherever we have real zeros. Real zeros, ooh, we only have one of them at 2. What's going to be true because it has multiplicity? Hopefully we agree. It's going to bounce or brush, whichever word you like. Okay, last thing to take a look at, x to the fourth. X to the fourth means that we have a positive coefficient, even degree, so it's going to go up, up. So, something like this, start up here, maybe grab the 20, then make sure that it bounces off of x equals 2, and we finish up, up. Now, does it have to look exactly like this? No. One thing that you do have to make sure of is that if you do some dip like this, can it come anywhere? Well, it could come really close to the x-axis. Can it touch or cross the x-axis? No, because then you would be adding in x-intercepts, and we know that we don't have any more x-intercepts, alright? So it doesn't have to look exactly like this, but it needs to be up, up, it needs to have this y-intercept, and it has to have a bounce at 2. Alright? Whew, that was a lot. Have a great day.